So hello again. Today we're going to look at inverse functions, and this time we're going to look at finding the inverse of a function. All right. So let's see how we do that. So we first looked at when a function was one-to-one, and then we looked at restricting the domain of a function. And this was all in preparation to find the inverse of a function and for that function that we find, that inverse, to actually be a function itself. So our first question is find the inverse of the following functions algebraically. Okay, so what do we do? So there are three steps for finding the inverse of a function. The first is we interchange the x and y values of our function. So here are functions f at x equals x minus 2. Let's let f at x equal y. So we have y equals x minus 2. We're going to interchange the x and y variables. So now we have x equals y minus 2. Second step is we're going to solve for y. So if we solve for y, we need to bring the negative 2 over to the left-hand side. So we have x plus 2. So therefore we have y equals x plus 2. And our final step, we're going to replace the y with the inverse notation. So our inverse function is f inverse of x equals x plus 2. So this is our inverse of our original function, f at x equals x minus 2. Now, if we want to check, how would we check? So to check that this is indeed the correct inverse, one of the properties of the inverse is, our function evaluated at the inverse function should equal the identity function, or just x. So let's try this. So we have f evaluated at our f inverse that we found. Okay, so we're using the composition of functions here. I believe this is something we will learn in time, but let's follow along. So f, our function f is x minus 2. So we're going to replace the x with f inverse minus 2. F inverse equals x plus 2. All that minus 2. And what do we get? We end up with x plus 2 minus 2. The 2 and the minus 2 cancel out to give us 0, and we're left with x. So we are indeed correct. Our f inverse function is x plus 2. All right, let's look at another example. So our second example is f at x equals 1 over x plus 2. So again, first step is let's let the f at x equal y, interchange the, let's try a different color, interchange y and x. So we have x equals 1 over y plus 2. Now we're going to solve for y. So let's cross multiply. We want to bring anything with a y. So in this case, the y plus 2 into the numerator. Good. And then we're going to solve for y. So we have y equals 1 over x minus 2. Okay. And then finally, we're going to replace y with the notation for the inverse function. So f inverse of x equals 1 over x minus 2. And again, we can check, but I'll leave that as an exercise. One last example. Oh, no, we have two. Oh, lucky us. Okay. So f at x equals negative x plus 1 all squared plus 3. So again, first step is let's let y equal our function. Let's use a different color, blue. Let's interchange the y and x values. So now we have not values, but rather variables. So x equals negative y plus 1 all squared plus 3. And let's solve for x. All right, so let's see, we'll bring the 3 over to the left-hand side. We'll divide both sides by negative 1. Good. Now we need to somehow get rid of that square. So what's the opposite of taking the square of something? That's the square root. Good. So now we have y plus 1 on the right-hand side and the square root of negative x minus 3. Okay, let's move over here. And now we're going to solve for y. So we're going to bring the negative 1 over to the left-hand side. And we have square root of negative of x minus 3. All that minus 1 equals y. Okay. All right. We might have to do a bit of fiddling with our domain, but that's okay. And then finally, we're going to replace our y with our inverse function notation. So f inverse equals square root of negative x minus 3 minus 1. Okay. So if you notice, we have the square root of what looks like a negative number. However, depending on what our domain is, that will be a valid statement. So if our domain is x values that are real, of course, such that x is, let's see, less than or equal to 3, then I think we're okay. So if we put any value of x that's less than or equal to 3, we will have a positive value under the square root. And I'm sure if we were to have a look at our original function, we'd be restricting our domain in that way, in some manner. Okay, one last exercise. Again, first step, let our function equal y. Interchange the x and y variables. And now let's solve for y. So to remove a square root, we take the square of both sides. And then finally, we add 1 to both sides. Okay, so therefore, our inverse function equals 1 plus x minus 1 over 2 all squared. Good. All right. So again, thank you for watching. If you have any questions, give us a shout, either by email or by phone, day or evening, and we look forward to seeing you again. Thank you.